Hello everyone, my name is Ryan Myers. I'm the undergraduate researcher doing the project Predicting Movie Profitability. I was helped by my faculty mentor, Dr. Arthur or Andy Alexander, who is a lecturer in quantitative methods for the Krannert School of Management. There are many aspects of a film that directly affect the success it will have at the box office. My project led me to these 9 aspects you see here: budget, A-listers, MPAA rating, release, past material, IMDb score, Rotten Tomatoes score, genre, and production. My overall hypothesis that got me interested in this topic was trying to find a way to build an equation that would predict movie box office revenue. To begin, I used financial information from past films to determine how accurate each aspect could be in predicting the worldwide gross success of a movie. I then took each value found and formed an equation that could be tested on more past films. Both of these were done in Excel using various functions including VLOOKUP and average. I then took the equation over to RStudio, where I could write code to represent the equation and test it on multiple other films more efficiently than I could in Excel. I would use this testing to adjust the variables to reflect the volatility of movie success. Moving on to the individual aspects of a film that reflect its revenue, we have the budget. On the graph to the right, you see the y-axis being movie revenue, and it reaches up to $3 billion, and then the x-axis has the movie's budget, which goes from right to left and reaches a height of 400 million. There is a correlation between the budget size and the box office success. When you take the ratio of revenue to budget, you get a range between 19.5 and 0.002, with an average of 2.66. This means that on average, a film is going to make 2.66 times its budget. Moving on, we have A-listers. A-listers are those actors and actresses who are household names and are going to be the reason that some people go to see movies. There was a paper done at Arizona University titled The Star Power in the Eye of the Beholder, a study of the influence of the stars in the movie industry, and it argued that actors have a stronger influence over the production financing than the box office success. In other words, an actor is going to have more power over how big a budget the movie is going to get, not how well it's going to do at the box office. I used this assumption in the beginning of my research, but found that it doesn't apply to those top A-listers. Top A-listers can have a profound effect on the box office success. I found the A-list factor to be 0.5 plus the number of A-listers over 3. And that brings us to the MPAA rating. These are the ratings that relate to the intensity of a film in regards to violence, nudity, language, adult content, etc. Ranging from most intense to least intense, you have NC-17, R, PG-13, PG, G, and then not rated usually falls between NC-17 and PG-13. Different ratings correlate to different potential revenue. Logically, this makes sense given that there are age restrictions to some of these that limit the film's ticket buyers. For example, if you're under 17, you cannot go see an NC-17 movie. The graph on the right shows the revenue per rating. Those numbers are going to be used in our equation. For example, a movie that's PG-13 is going to make on average $35.4 million. Another factor is when the movie is released during the year. When a movie is released can affect the revenue. Movies tend to make more money in months where people have the most free time. As you can see, there's high revenue in the summer months and in December, summer break, Christmas, or winter break. You can also see in August and January it has the lowest revenue because breaks are ending. The numbers that correspond to the top of the pillars are going to be used in the equation for whenever the movie is released. There is also past material, basically what is the film based on. People are more inclined to go see something if they already have some sort of relationship with the setting, character, or style. The graph you see to the right shows the different sources and how much money they make. Currently, graphic novels or comic books make the most, and there's also spin-offs or sequels. The numbers corresponding to the tops of these bars are going to be what's used when predicting the revenue for each source. Here we have IMDb, or the Internet Movie Database. This site contains information about films including box office numbers, award history, user rating, performers, directors, etc. The user ratings shown on this site are out of 10 and they're by the general public. Anyone can create a free account with IMDb and post their movie reviews. Using a film's rating and its box office numbers, I was able to find that on average a film is going to make $38.9 million per one IMDb rating point. For reference, the highest ever ranked IMDb movie is Shawshank Redemption with a score of 9.3. This captures the audience opinion of the film, and many moviegoers put significant faith in these ratings. While IMDb captures the general public's opinion of the film, Rotten Tomatoes reveals the critic's opinion. This rating has the ability to capture the eye of the audience and can generate more excitement for the film. This score is often used in a movie's marketing campaign. For example, recently the movie Knives Out held a score of 99%, which they talked about in all the trailers that were on television. Using a film's rating with its box office numbers, I was able to see that on average, a film is going to make $4 million per one Rotten Tomato rating point. That brings us to genre. Different genres elicit different box office responses. Movies often fall under multiple categories, so for my calculation, I use the movie's top 3 categories. The graph below shows how much money it's going to make per genre. The type of production can also affect the amount of viewers. People are drawn to different forms of animation and live action. The reason you don't see live action alone at the top is because of the sheer number of live action films. You get a lot of successful ones and a lot of not so successful ones. The numbers at the top of each bar are going to relate to how much that money is going to make per production type. Using these variables, I created the first prototype equation. In theory, if you took what a movie was going to make based on the individual aspects and averaged them, you would get what the movie would make overall. This led to more of just kind of a generic result for a movie. It was around 150 million. With no X factors that would lead to success or failure of a movie in the equation, the results were all quite similar. Through many tests, I found that the budget multiple did not accurately reflect how well it would do at the box office. So instead of just taking 2.66 times the budget, I took 2.66, rose it to budget divided by 100 million, and multiplied that by the budget. Using that in the average equation better understood how it would do at the box office. In addition to this, I added the A-list factor, which was 0.5 plus the number of A-listers over 3, and you multiply that by the average. The equation was still missing something. It was able to see if a movie was going to do well or not so well, but not on the scale that they were performing. So I decided that there had to be some sort of X factor that would relate to a movie doing really well or really poorly. This X factor was going to be weighted differently in the average equation, since it was more important to the public. This factor would have to be based on different numbers depending upon which aspect of the film was deemed the X factor. Only a subset of categories could work as an X factor: A-listers, past material, movie score, and production. If the X factor that's going to bring in moviegoers is the A-lister, then you square the number of A-listers when you use the A-list factor. If the X factor lies in the past material, you use these. For a novel, you take the corresponding value for a fiction book, multiply that by reviews on Amazon times 10 divided by Amazon bestseller ranking. For a movie remake, you take the corresponding value for a remake, multiply that by the number of IMDb reviews on the original divided by 1,000. For a graphic novel or comic book, you take the corresponding value for the graphic novel and multiply that by the number of related films and or literature. If the X factor for the movie is the score or the rating for IMDb, you take the IMDb score of the film, multiply that by the film's IMDb score, divided by the corresponding value for the IMDb, which is the 38.9 million, and then you multiply that by 100 million. If it's in the production, for example, animated films like Disney animated movies, you take the digital animation corresponding value, multiply that by the Rotten Tomato score minus the IMDb score. Using the final equation and the X factors, here are some results for movies based off books. You can see the difference in expected to actual of the revenues at the bottom of each, and while they are large numbers, they are only a small percent change from the actual. Here are some examples of remakes. You can see Jumanji and The Lion King being very successful remakes because they had multiple high A-list actors and actresses. Charlie's Angels was a little less successful just because it didn't have as many top A-listers. Here are some examples of animated movies where the digital animation was the X factor in getting people to come. The main difference was Tangle's lower Rotten Tomato and IMDb ranking, as well as its lack of an A-lister. Here are a couple of examples of movies based on true events, where the true events are the X factor in getting people to come. Here are examples of comic book movies. You can see Avengers Endgame, highest grossing movie of all time, because it's the culmination of 23 previous movies. Justice League, however, did not do as well because it only had 2 or 3 movies in their universe before they came out. Here's a movie that really didn't have any X factors and fits the equation as is. Movies have 9 aspects that directly affect its revenue. Predicting this revenue is crucial for movie studios to avoid financial disasters. This equation is effective in predicting these outcomes, but there are still a few intangibles that can affect a movie's run at the box office.